Hey guys, welcome or welcome back to Michelle's STEM Journey. I am Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2005 10A Problem 19 and it deals with algebra. I hope you all enjoyed this video and let's get started. The problem states 3 1-inch squares are placed with their bases on a line. The center square is lifted out and rotated 45 degrees as shown. Then it is centered and lowered into its original location until it touches both of the adjoining squares. How many inches is the point B from the line on which the bases of the original squares were placed? Okay, so I'm gonna label some stuff. I'm going to label this point and this point as D, and then E, and then this point as C. So basically it tells us that it is lifted out and it is rotated 45 degrees and it's lowered and until it touches both of the two squares next to it. Well, it will drop until DE. This is 1 inch. And that's just because, each of the squares, it tells us that is 1 inch. And so for it to perfectly touch both of the squares, that means that must be 1 inch as well. And so you kind of have to imagine this part, but we know that this is 45 degrees. And that's because this was the original square once it was lifted out. And so we'll just pretend that this at point E right here, before it was lowered into the location where it is right now, before it was lowered, it sits like the red square that I drew. But once it turns 45 degrees and it's lowered, this point right here goes to right here. And so it kind of just like rotates like that. And so the part that it rotates is 45 degrees. And it already tells us that. And so we know that this angle right here would be 45 degrees because it tells us that. And so you kind of just have to imagine it, I guess. You have to imagine like the part that it rotates and which part corresponds to 45 degrees. But now we know that that's 45 degrees, then that would be a 45, 45, 90 triangle because we know that this is a right angle. And so we can use the formula 40, 45, 45, 90 triangle, or we could just use Pythagorean theorem. I'll just use the Pythagorean theorem. We know that I'll just let DC be x, so it'd be x squared plus x squared is equal to 1 squared. That'd be 2x squared is equal to 1, x squared is equal to 1/2, x is equal to the square root of 1/2. Rationalize the denominator, we get radical 2 over 2. So that is DC, which is also CE. And we don't really need to know that to figure out what it's asking us. It's asking us the distance. Here, I'm going to clear some of the stuff first. It's asking us for the distance from point B all the way to the bottom. So we want to figure out the distance of here. So we can get the distance from BC minus, and I'm going to let this point be F, the center point right here. So essentially what I'm trying to do is to figure out the whole length of BC minus FC, which is just this upper part, and then add 1 to it because that is 1. So right now we figured out DC or EC. And so that's easy because now we just want to figure out the height of the triangle. Well, I'm going to use the area formula to find out this. So DE, which is 1, times what we're trying to find, which is FC, times 1/2. That is the formula for the area of the triangle DEC. Well, this will be equal to base, which is, I'm going to use the base as CE, which we know is radical 2 over 2, times DC, which is also radical 2 over 2. So I'm going to square that, times 1/2. We get 1/2 minus, or no, times 1/2 is equal to FC times 1/2. 1/2 can cancel out, so FC would be 1/2. Okay, so now we know FC is 1/2. Well, we want to find out BC, so we can subtract FC from it. BC is just the hypotenuse of triangle B, or I didn't label this, I guess, but it'd just be the hypotenuse of this triangle. Well, we already know that the sides are 1. It'll be 1 squared plus 1 squared, which is just 2, is equal to BC squared. So we can just square root that. So BC would be the square root of 2. And so we can just do BC minus, I'm going to write out the formula that I just said, BC minus FC, and we can just add 1 to that. So BC is square root of 2 minus FC is 1/2, and then add 1 to that to get the square root of 2 plus 1/2. And so the answer would be D.